This is the USS Ohio-class submarine, the largest submarine ever built for the United States Navy. Powered by a nuclear reactor and capable of carrying nuclear weapons, torpedoes and guided missiles, Ohio-class submarines are the deadliest submarines ever built for the U.S. Navy. In this video, with the help of 3D animation, we're going to take a look at how this powerful submarine works. We'll start with how they are designed and constructed, and then we'll see the functioning of each compartment. Then we'll take a deeper look at how underwater torpedoes, guided missiles, and intercontinental ballistic missiles work. And finish it off by looking at how the diesel engines and the nuclear engine powers the entire submarine. So without further ado, let's begin. Built in 1976 and commissioned in 1981, the U.S. government wanted to build 24 Ohio-class submarines, but only 18 were built. There are two types of Ohio-class submarines, the SSBN and the SSGN. SSBN submarines carry ballistic nuclear missiles like the Trident-2, and the SSGN carries guided missiles like the Tomahawk subsonic cruise missile. These submarines are huge. They are 560 feet long, 42 feet wide, and can dive more than 800 feet underwater. When surfaced, they displace 16,746 tons of water, and when submerged they displace 18,750 tons of water. Here's a human for scale. The submarine carries 15 officers and 140 enlisted crew. Let's look at how they are built. The internal structure is made of multiple supporting structures called bulkheads. They not only act as supporting structures but also as walls between two rooms. They have two dome-shaped bulkheads, one in the front and one in the back. The outer body, known as hull, is designed to withstand extreme pressure underwater. They are made of anechoic tiles, or rubber tiles, to absorb sound waves. The submarine has three large logistic hatches. One in the back, one in the middle, and one in the front. These hatches allow rapid transfer of supply pallets, machinery components, and equipment replacement modules. The forwardmost section is where you'll find the large sonar dome. Submarines use sound waves to detect enemy submarines underwater. They emit sound waves and receive sound waves which are bounced off of the enemy submarine to detect its position, speed, and depth. The crew can walk through the tube to access the sonar dome for repairs or for maintenance purposes. Inside the forward dome-shaped bulkhead, you'll see three different floors. The topmost floor is the radio room. This is where the vessel's communication is handled. Submarines use very low-frequency radio waves to penetrate the seawater. These waves have shorter wavelengths, which makes it difficult for the enemy submarines to detect their location. The submarine has to be in a shallow water, or it has to use a buoy to effectively transmit the radio waves. Below the radio room, there is an officer's quarters, also known as wardroom. This place is reserved only for the officers. This is where the officers eat, study, do paperwork, socialize, and have meetings. Behind the officers' quarters is the officers' restroom. And right below that is the officers' berthing. This is where the 15 officers sleep. The rest of the 140 crew have a separate berthing near the missile silos. On the topmost floor behind, you'll find the sonar room. This is where the large bow-mounted sonar is controlled from. Here's where the enemy submarines are detected, located, and tracked. The person who operates the sonar is called Sonar Technician Submarine. The floor below that is the officer's study room. Here's where the officers do most of their paperwork. The floor below that is the main medical room. These rooms are well equipped with extensive amount of medical, dental, and surgical equipment, as well as a large library of texts to aid the medics. This facility is open to everyone on board the submarine. This is where it gets interesting. The top of this bulkhead section is where the control room is located. The periscopes, the dive planes, and the ballast tanks are all controlled here. The periscope is an optical instrument used to look above the surface of the water. They can be as long as 18 meters or 60 foot in length, and can be rotated to look at the target. Once the submarine dives deeper, the periscopes are retracted inside the submarine. Next to it, there's a main hatch which is used by the crew to observe the surrounding before the submarine dives. To maneuver underwater, the submarines use a type of control surface called dive planes. The horizontal planes keep the submarine stable while diving and surfacing. The submarine helmsman and planesman in the control room controls the dive planes. The vertical stabilizer, or the rudder, is used to make a U-turn, just like in an airplane. The horizontal planes are controlled precisely to achieve steady dive, or surfacing, along with the help of ballast tanks. The Ohio-class submarine has two huge tanks called ballast tanks, one in the back, and one in the front. The submarine dives and surfaces mainly because of these two tanks. When these tanks are filled with water, the submarine dives. When they are emptied and the water is replaced by air, the submarine surfaces. When the tanks are completely filled with water, the submarine achieves negative buoyancy and dives completely. When half of the tanks are empty, the submarine achieves neutral buoyancy, rises up, and maintains the depth. When the tanks are completely empty, the submarine achieves positive buoyancy and rises above the surface of the water. To keep the crew healthy and smart, there's a gym and a study room. And to keep them clean, a laundry room is available right below the study room. Below the laundry room is where the deadly torpedoes are stored. This is the torpedo room. This is where the torpedoes are maintained, stored and fired. Let's take a deeper look at it. The Ohio-class submarine uses MK-54 lightweight torpedoes and MK-48 heavyweight torpedoes. The MK-48 torpedoes are advanced capability heavyweight torpedoes. They are designed to sink deep-diving nuclear-powered submarines and high-performance surface ships. They weigh 3,434 pounds and are 5.58 meters long. They use high-explosive warhead that weighs around 647 pounds, and they also use any unused fuel as explosives. They have a range of 24 miles, and are guided with the help of a long wire. In the front, it has a common broadband advanced sonar guidance system, and a proximity fuse which sets off the warhead when the torpedo gets closer to the target. It has a small swash plate piston engine for propulsion. The propellers in the rear section provides necessary thrust to the torpedo. The rearmost section is called the guidance wire spool. This is where the 15-mile-long wire is stored. The torpedo, for most of the time, is guided towards the target with this long wire. This wire is cut off when the torpedo gets closer to the target, and then the guidance system takes over. Let's see how it works. First, the torpedo is placed inside the torpedo tube and the door is closed. Then the torpedo tube is filled with water, and the water pressure is increased to match the pressure outside the submarine. The torpedo tube door is opened, and high-pressure gas is pumped into the tube to push the torpedo out of the submarine. The guidance spool remains inside the submarine. The torpedo comes out at high speeds and moves towards the target. It is guided towards the target with a long guidance wire. The combination of wire guidance and onboard guidance system makes it a deadly high-precision torpedo. When it gets closer to the target, the wire is cut off and the onboard guidance system guides it towards the target. The submarine also carries anti-torpedo decoys. When an enemy submarine launches a torpedo, a decoy is launched to counter the torpedo. This decoy creates a false submarine signature while continuously changing direction. The enemy torpedo now follows the decoy instead of the submarine, and eventually run out of power after following the decoy for too long. Behind the torpedo room, there is an office room. This is where the rest of the crew do their studies and paperwork. Behind the office room, there's the navigation room. With the help of Global Positioning System, Inertial Navigation Systems, and the bow-mounted BQR-19 Active Collision Avoidance Radar System, the submarine can navigate through deep waters, safe and secure. Below the navigation room is the deadliest room of all, the Missile Launch Control Room. This is where the guided missiles, or the intercontinental ballistic nuclear missiles, placed inside the missile silos, are launched. When the submarine receives orders to launch the missile, the commanding officer and the executive officer will announce the orders to the crew. There are a total of 24 missile silos on Ohio-class submarine. The SSGN-type submarine carries guided missiles, especially the Tomahawk subsonic cruise missiles. Each of these missile silos can carry up to 7 Tomahawk missiles. A total of 154 Tomahawk missiles can be launched from this submarine. The Tomahawk missile is a long-range land attack subsonic cruise missile. It weighs 2,900 pounds and is 18.3 feet long. It can carry 1,000-pound high explosive warhead and has a wingspan of about 8.9 feet. It can cruise towards the target like an airplane with the help of a small F-107 turbofan engine, and has a range of 1,500 miles. Let's see how it works. Before the Tomahawk is launched, the wings, fins, and the air scoop are in the retracted position. The solid rocket booster pushes the missile vertically to a certain altitude. After that, the missile turns to the horizontal position, and the booster section is ejected out. Immediately, the wings, fins, and the air scoop extend outwards. The small turbofan engine starts, and the cruise phase begins. With the help of Global Positioning System, Inertial Navigation System, and the TRCOM system, the missile now flies hundreds of miles toward the target, like an airplane. It flies at very low altitudes to evade enemy radars. Once the target is in sight, the missile hits it with great precision. The Tomahawks were designed to carry the M80 nuclear warhead, but later they were retired. Other variants of this missile are the anti-ship variant, surface-to-surface variant, and a submunition dispenser variant. Let's see how they are launched from the submarine. Just like the torpedoes, the missiles are also pushed out of the missile tubes with the help of high-pressure gas. Once the missile comes out of the water, the solid rocket booster starts, and the missile moves towards the target. The SSBN-type submarines carry intercontinental ballistic missiles, like the Trident-2. The Trident-2 is a 3-stage ICBM. Each stage is powered by a solid fuel rocket motor. It weighs 130,000 pounds, is 44.6 feet long, 6 feet in diameter, and has a range of more than 7,500 miles. It can carry 12 to 14 nuclear warheads, and can travel 24 times the speed of sound. When the Trident-2 missile is launched, the telescopic nose spike extends outwards. This spike reduces the aerodynamic drag by 50%. The first stage motor propels the missile to higher altitudes. "65 seconds later, the first stage separates from the missile, and the second stage motor starts. This motor also burns for 65 seconds. Now, the second stage motor, and the nose fairing is jettisoned, and the third stage motor ignites. This stage carries multiple individual re-entry nuclear warheads, and it burns for 40 seconds. When the third stage reaches the targeted area, the nuclear warheads are released, and they enter the Earth's atmosphere. At this point, their temperature can reach up to 20,000 degrees Fahrenheit. Each of these nuclear warheads are 8 times more destructive than the ones dropped on Hiroshima. Just like the Tomahawk missiles, the Trident-2s are also pushed out of the silos by high-pressure gas. Once the missile leaves the water surface, the first stage motor starts, and the missile moves towards the target. Below the missile control room is the dining hall and the galley. Most of the food they eat here are canned, dried, and frozen food, because the fresh food lasts about 2 weeks only. Below that is the auxiliary diesel engine. There are 2 diesel engines on board. They can generate up to 325 horsepower. These engines are used as backup power system for the nuclear reactor heat removal and emergency propulsion for the submarine. On either side of the missile silos, large number of PDX-57 lead-acid batteries are stored. They are used as emergency backups during power outage in the submarine. They store 2.6 megawatts of energy and are 2,100 pounds heavy. Below that is the crew's berthing. This is where all the 140 crew members rest. Adjacent to it, a small medical room is available. And right below it is the crew's restroom. A small storeroom is next to it. This is where the crew's food items are stored. This section is the Purifier section. This is where breathable air and drinkable water are produced and supplied throughout the submarine. The submarine uses seawater to carry out the reverse osmosis process, where the seawater is converted into drinkable water, by removing large particles such as contaminants and sediments like chlorine, salt, and dirt. This purified water is subjected to electrolysis, where the oxygen molecules are separated from the hydrogen molecules, with the help of electricity, to produce breathable air. Right below it is the hovering pump. These pumps control the flow of seawater in and out of the ballast tanks. They basically control the diving and surfacing of the submarine. Behind them is the powerful nuclear power plant that powers the Ohio-class submarine. This is the S8G Nuclear Reactor, where the S indicates that it's a reactor used on a submarine, 8 indicates that it's an 8th-generation core, and G indicates that it was manufactured by the General Electric Company. This reactor is 42 feet in diameter, 55 feet long, and weighs 2,750 tons. It's a pressurized water reactor-type power plant, where the water is the main coolant. The water is pumped under high pressure to the reactor core, where it is heated to high temperatures. This high-temperature water is then sent to the steam generator, where it transfers the heat to another system containing low-temperature water. This secondary tank water gets converted to steam, which is used to generate electricity, and to turn the turbine blades for the submarine's propulsion system. It uses weapons-grade highly enriched uranium-235 isotope. This radioactive material is used to create a nuclear fission reaction, where it's bombarded with a neutron. This creates a chain reaction, where the nucleus splits continuously, releasing extremely high amounts of thermal energy. This reactor can power the submarine for 20 years. The only limiting factor is the amount of food carried by the crew on board. Behind the reactor, there's a maneuvering room. This is where the nuclear reactor, as well as the power and speed of the engine, is controlled. This is the rearmost section of the submarine, the turbine section. The steam produced by the reactor is used to turn the gas turbine generator. The turbine turns the submarine's propeller, known as screw, and it also generates electricity by converting mechanical energy into electrical energy. When the steam cools down and condenses back to water, it goes back into the nuclear reactor, and the process repeats. This turbine generates 35,000 shaft horsepower, enough to propel the submarine to a speed of 29 miles per hour, underwater. The rearmost part of the submarine is the propeller, known as screw. These screws are designed specifically to reduce the sound underwater. When they rotate, they create water bubbles. This is called cavitation. When these bubbles burst, they create noise, which can be picked up by the enemy's sonar system. The blades of the screw are designed in a specific way to reduce the cavitation and to increase the efficiency. To this day, the design of these blades is a well-guarded military secret. This submarine also carries a small submersible called SEAL Delivery Vehicle. The Special Operation Forces like the U.S. Navy SEALs use this tiny submersible to enter enemy territory without being detected and without giving away the position of the submarine. They can detach and attach to the submarine at shallow waters only. This is how America's one of the most powerful nuclear submarine, the Ohio-class submarine, works. Hope you enjoyed the video. Thank you for watching.